Hey guys, let's discuss new question. So new round 4, AI engineering from Apple interview loop. And here you have to design on-device AI assistant Apple Intelligence style. Okay, so means you have your iPhone, okay, and you need to design AI assistant for it, where you can similar to ChatGPT, okay, but in ChatGPT your question, your data is going outside, right, and then at some other server it is getting processed and then it is returning you the response. But here on device we will do, okay, on device he will be able to connect your messenger, your calendar, and every other apps, okay, from your iPhone. So this is like a personalized ChatGPT for you, and the secured one, okay. That is what we need to design. Now let's discuss functional requirement in detail first. So AI assistant interaction you would be required here, okay. Now, okay, so the first one is AI assistant interaction you would be required. So user can interact with the assistant with text, voice, and images, okay, similar to ChatGPT. We are able to send the voice in images and text, okay, to him. Then assistant understand the user's request and generate a response. Support multi-turn conversation with conversation context. On-device processing. So process sensitive requests locally on device wherever possible. Use the device NPU, GPU, CPU for AI inference, and avoid sending private data to cloud unnecessarily. See, we will use the cloud API, but when your device is not sufficient to process that request, then only, okay. So we'll be using that, but will not be on the priority. Okay, now personal context. So assistant can use relevant information from your messages, your calendar, contact, email, photos, files, device setting, right? So retrieve only the context required to the answer to request, okay? Now writing and summarization. So rewrite text in different tones, let's say, and then summarize email, messages, document, and notifications. Generate replies and text suggestion, proofread and correct grammar. Now fifth one is image intelligence. So understand images on device, okay, then extract text from images, and after that summarize or describe images, search photos using natural language queries. So NLP also you will be using here. Task automation. Create reminders or events, search contacts, draft messages, perform supported actions across application, ask for user confirmation before sensitive action. Okay, so human in loop also we will introduce here. Cloud AI fallback. So if the request is too complex for the device, securely send it to cloud AI service. Okay, like we use the OpenAI APIs, right? We put some credit there, and then we can use their APIs, so similar to that. Now use on-device premises first wherever possible. Provide a seamless transition between on-device and cloud inference. Eighth one is privacy and user control. So user can control which application or data the assistant can access. Sensitive operation required explicit permission, and maintain audit history or assistant action where appropriate. Now non-functional requirement. So non-functional requirement will be like privacy, the very first thing, okay, which is very important. Keep personal data on device wherever possible. And security, so encrypt sensitive data and secure communication with cloud services. And low latency, simple AI request should respond within 1 or 2 seconds. And then after that offline support, so core AI capabilities should work without an internet connection. Battery efficiency, so minimize CPU, GPU, NPU usage and battery consumption. Definitely, right? Here you are using device GPU, CPU, okay, NPUs, so users battery consumption should be less. Now software engineer, what he will say regarding the design, he will say that I would first determine whether the request can be handled locally on the device. For simple task I would use on device model. If the request requires more capable reasoning or data, cloud data, I would securely send the minimum required information to the cloud AI services and return the response to the device. Okay, so basic architecture will be something like this. So user request will go to AI assistant UI, okay, your device UI. your text to voice or images as input it will take, and it will display the response and then it will go to context manager. Okay, after UI it will go to context manager. It will access the device data like messages, calendar, contact, photos, files, okay, and retrieve the relevant context. From there it will go to request router. Now request router will route your request to on device model or the cloud AI. So from there you will get the response. Okay, response manager will send you the response and user will get the response on the device, on the UI. So prompt flow will be something like this. User provide a request, assistant identifies the intent, context manager gather relevant context. Okay, then request router determines local or versus cloud execution. Okay, then routing thing will happen there. Model generate the response is validated and formatted. Assistant return the request to the user. Now what is the work of context management? What is context management here? So context can include current conversation, user's request, relevant application state, recent interaction, user preference, and device state. Okay, only the context required for the device should be provided to the model and not the any other extra information. Okay, now API communication. So for cloud execution, use secure HTTPS communication. That is very first thing. Okay, if you are calling outside, and then authentication of the device or user. Encrypt data in transit. Okay, means whenever you are sending data, it is not in the database, not in the when it is traveling across the network, that time it is in transit state, right? So that time also encrypt it. Minimize payload size using compression or something. You can use any other algorithm there. Then handle request timeouts, retract transient failure carefully, and provide graceful fallback when the network is unavailable. Okay, so now let's talk about 6 follow-up questions here. When I've just taken the important one only, so 6 or 7 follow-up questions. So the first one is when would you use the on-device model versus cloud AI? Okay, so use the software engineer will say that use the on-device model when the task is relatively simple. Okay, then second is low latency is important, the request contains sensitive information, network connectivity is unavailable, and device has sufficient compute resources. Okay, NPU, GPU, LPU, NPU, CPU, GPU. Okay, use the cloud model when the task requires more advanced reasoning. Okay, the large context is required, the device cannot efficiently run on the required model, and external cloud services or capabilities are required. So now what senior software engineer will say, he will introduce a model or routing layer there. Okay, so something like this. See, this is the similar diagram what we have seen. So user request will go to AI assistant UI, from there to context manager, from context manager to AI router. Now here he will route on the small model or medium model or large model. Okay, so small model will be your on device execution, let's say. Medium model will be your again on device execution, but large model cloud execution. From there it will gather the response, okay, and through response manager, and then user will get the result on the screen UI. Okay, the router can consider task complexity. Okay, so on which basis he will route the request. First one is task complexity. If it is very complex task, then it will route request to the complex task manager. Complex model, then model capability, context size, device hardware, battery level, network availability, latency requirement, and then privacy sensitivity. So what architect will say? Architect will say that I would make the routing decision policy driven. Okay, now here he will introduce a policy, so that policy can be used by many teams, right? So for example, user request first will go to policy check. See, if it is a sensitive data, then just go with the on device. Okay, if it is non-sensitive, then go with the capability check. Okay, whether it is a device capable, so go to device, or if it is a cloud needed, so cloud. So policy, what policy he has introduced here? Here he is checking whether it is a sensitive data or non-sensitive data. If it is non-sensitive data, again he will check device capability or cloud needed. Okay. Now privacy should be first class routing constraint, not simply performance optimization. Okay, first class means very first we have checked that. and after that all the performance thing and everything we have done later. Follow-up question 2 is how would you optimize latency? So software engineer will say that he will keep frequently used models loaded, okay, reduce unnecessary API calls, stream model responses where appropriate, avoid sending excessive context, and then use asynchronous processing. What senior software engineer will say that he will use model quantization. Model quantization means if it is a 64-bit precision, then use 32-bit precision, okay, so there you will save, you will optimize it, okay, then optimize the latency, then because you will save some tokens there. Now smaller specialized model you will use wherever possible. Prompt caching, KV cache reuse, okay, then streaming inference, request balancing where appropriate, context compression, local reprocessing, pre-processing, and then connection reuse. Now architect will say that optimize latency across the complete pipeline. So what is your complete pipeline? First user input, then your context retrieval, okay, after that routing, model inference, tool calling, some external tool if you require to call, then response generation. So this is the complete life cycle, and you will optimize latency for each pipeline, okay, throughout the pipeline. So you will measure P50, P95, P99 latency. 50% request what is the latency for the 50% request, then what is the latency for 95% request, and for 99% request, okay. So now second is time to first token. First token, how much time it is taking, then token per second, context retrieval latency, model switching latency, and then network latency. Okay, use the device for latency sensitive preprocessing and small inference while sending on the appropriate workloads to cloud infrastructure. Follow-up question 3 is how would you manage personal context? Okay, so every user will have its own AI assistant on his device, right? So there would be a personal context definitely. So software engineer will say that he will maintain a context store containing relevant user information and retrieve only what is necessary for the current request. Senior software engineer will say separate context into different categories. So like short-term conversation context, application context, long-term preferences, and then personal memories, temporary task context. Okay, so use relevant filtering before sending context to the model. Architect, what he will say that personal context should be designed around data minimization and user control. So here he is talking about data minimization, cost efficient system, and then user control, okay. So personal context will go to either it will go to device context or cloud context, okay. If it is going to device context, then you will store that in the local storage, okay, and then locally you will retrieve it. And for cloud minimum required context, okay, so minimum information only you will send to cloud and then retrieve from there, and then you will securely process that data, okay. Important principle, so store sensitive context locally wherever possible, okay. This is what architect will supposed to answer. Then encrypt stored context, minimize cloud transmission, okay. Whatever is possible on device, just do that. Otherwise send it to minimum context, send it to cloud device. Give user control over stored context, allow deletion, okay. Then apply access control, separate application context from personal memory. The assistant should not automatically expose a user's entire personal history to every model invocation. So there the security thing should come into picture, okay. Now follow-up question 4 is how would you design privacy first AI? So software engineer will say that encrypt data in transit, very first thing. Then encrypt sensitive data at rest also, even if it is you have already stored in storage, that time it is in rest stage, right? So that time also it should be encrypted. Authentication request, minimize data sent to the cloud, and avoid logging sensitive prompts. Okay, now what senior software engineer is supposed to answer here? He will say that you can add on-device processing, then data minimization, secure storage, access control, short-lived credentials, use some short-lived one, okay, and then reduction of sensitive information, privacy aware logging, and secure model communication. So architect will give the policy should be part of the architecture. Means first the policy privacy policy layer will come, and from there on device and cloud processing will happen. Okay, so here sensitive data and here minimized data will be considering. Okay, the system should follow, he will say that system should follow data minimization, okay, least to privilege, then local first processing, encryption, explicit consent, audible access, secure deletion, and then privacy preserving telemetry. The fundamental principle is if the task can be completed safely on device, avoid sending the user sensitive information to the cloud. So your model is based on this one line only. Okay, fine. So now follow-up question 5 is how would you design model orchestration. So model orchestration means you are using here multiple model, so there should be a one model orchestrator who will manage all these models. Okay, so software engineer will say that start with a simple router that chooses between your on-device model or cloud model. That is the very first thing, right? Senior software engineer will say that introduce a specialized model. The router select the appropriate model based on the request. Okay, small model, medium model, complex model. Architect will say that build a model orchestration layer capable of managing model selection. Okay, this orchestration layer, just create one orchestration layer. And what is that layer's work? First one is model selection, model versioning, okay, then routing policies, fallback, tool invocation, context retrieval, safety policies, model health, latency, cost, and then privacy requirement. For example, AI request will go to AI orchestrator. Okay, from there it will either go to local LLM, RAG, or cloud LLM, and then from there it will go to tool layer and then response. Okay, so now follow-up question 6. No, this is not the last one, this is the last second. So how would you support offline AI? Let's say user is not connected to internet, okay, right now. So how this offline AI will work? It should give the capability for this offline processing also, right? So software engineer will say keep a lightweight model on device for basic task. Okay, for example, text summarization, rewriting, simple classification, basic question answering. At least these things the model should provide offline. Senior software engineer will say the system should detect network availability, like request will go to network check. Okay, if it is online, then go to router. If it is offline, then go with the local model local LLM, and then from router it will go to cloud AI. When it is offline, so use local model, use locally available context, queue operations that can safely be deferred, and clearly communicate when cloud capabilities are unavailable. So architect, what he will say? He will say offline capability should be designed as the degraded but functional mode, not simply an error state. Then the system should define which feature work offline, which model are available, maximum context size, local storage limit, deferred operations, and synchronization when connectivity returns. Okay, follow-up question 8 is how would you use federated learning? Okay, so software engineer will say that instead of sending raw user data to central server, the model can be trained or improved using data locally on device. So senior software engineer will say the simple approach. See, you have a multiple device. Okay, so this is your device 1, device 2, and device 3, and you will have the local training, okay, on each device, and then you will update the model, and then aggregation server will aggregate all these learning, okay, from different devices, and then it will improve your model. Only model updates are aggregated rather than directly collecting raw user data. Okay, now what architect will say, this is the last one. So federated learning can support privacy preserving model improvement, but it requires carefully design around your secure aggregation, differential privacy, then model update validation, device compute constraint, and model versioning. So the system should minimize the amount of sensitive information that can be inferred from model updates. So that's it. Thank you.